So welcome to all attendees from various countries in this difficult period of time with the COVID-19. So I'm Christophe Offrère, the CTO of Forcia and the Deputy VP of the FISITA Technical Committee. I'm going to moderate the conference. But first of all, we are going to watch a quick video delivered by Chris Mason, the CEO of the FISITA.
Hello, good afternoon, good morning, good evening to you, wherever you may be joining us from. My name is Chris Mason. I'm CEO of FISITA, talking to you from my study here in the United Kingdom today. As we pull this new program together at this most challenging of times to support the FISITA community in a way that only FISITA can. I have to say, I'm absolutely delighted with the work of the team and our technical community and volunteers in pulling this FISITA online conference program together for you so quickly and to such a high quality standard. And this is the first in what will become a series of FISITA online conferences looking at different topical technical subjects over the coming months. I'm absolutely delighted with the speaker lineup that's been pulled together for us today, and my thanks go to FISITA, to MIT and to NEO, and the speakers we have lined up, and especially my thanks to Christophe, who will be chairing today's session. So without holding up proceedings any longer, why don't I hand over to the real experts and to Christophe, who will support us as we spend the next hour or so exploring today's subject matter, which is, of course, human-machine interface. So over to you guys, and thank you for joining us, and I'll see you again very, very soon.
Okay, so thank you to Chris. Of course, he's supporting this online conference. So coming back to the conference itself, so this is the first FISITA online conference of this kind that we are going to organize today. The goal of the online conferences is not to give you a deep knowledge in the different topics we are going to cover. The time spent, of course, is too short for that. But we want to enlighten you on key engineering trends that are relevant for the automotive industry and give you the possibility to ask questions to our speakers or panelists. For this time, so we have chosen the human-machine interface or human-machine interaction as the first topic we are going to deal with today. The relationship between the vehicle and the occupant are going to change a lot in the future, and at the same time, the car is becoming more and more automated and intelligent. For example, regarding automated vehicles, the traditional control of the car by the driver will change to more control of the driver by the car, especially for transition phases when the driver will have to re-engage after an autonomous driving sequence. And this is all about human-machine interaction or human-machine collaborations, I would say. But there will also be other functions integrated in the car, which will need to identify the occupants, like an occupant ID, and propose customized experiences and services for comfort, infotainment, safety, working sessions, gaming, etc. And this is also all about human-machine interfaces with a lot of predictive associated functions. The technologies are coming, the way to interact with the vehicle is changing and not fully stabilized today. So we propose you to attend the conference where we tackle some of the issues related to human-machine interfaces, starting with human-centric investigations, then relevant technologies, and at the end, an implementation for a non-traditional OEM, which is NEO. One practical comment. You have on the right-hand side of your screen the possibility to ask questions by chat. Don't hesitate to do it. We'll collect them and ask them at the end of the conference. So now, let me introduce the first speaker. The first speaker is Brian Reimer. So he's a brilliant research scientist in the MIT Center of Transportation and Logistics, which aims to find solutions for the next generations of human factor changes. So he founded also and leads the Advanced Vehicle Technology Consortium, and he got also different innovation awards. So now the floor is to Brian. Thank you, Brian, and good luck for your presentation.
Thank you for the introduction, and I hope that everybody is in good health and safe in these turbulent times. I'd like to talk a little today about what are production advanced driver assistance systems and automated driving systems telling us about the migration forward on our path to automation towards one that I would consider of collaborative driving versus autonomous driving. And most importantly, I think that we need to look back for a moment. The history of our pursuit of driverless technologies is not new. All the way back in 1926, in the context of remote control, the Milwaukee Sentinel in the US documents the first move towards driverless vehicles. In the 1950s, GM invested copiously in this topic. In the 1980s, several prototypes. The modern era of driverless and automated technologies really was kicked off with the DARPA challenges in the 2000s and the introduction of the Google self-driving car program just over 10 years ago. In the 10 years since, we have invested countless billions of dollars in the pursuit of this technological marvel. What's next? I'd argue it's a drastic shift in how we live and move, but it is one that will not clearly take the driver out of the driver's seat anywhere as quickly as the forecasts 5 or 10 years ago may have presumed. When we think to the context of what autonomy means to different people, there are a number of different viewpoints in this topic. As I highlighted in a piece that in my Forbes blog in 2018, we haven't yet begun to agree on what are we trying to achieve here. Are we trying to achieve vehicles and vehicle systems that just encompass hands-free driving, many of the vehicle systems that are being produced today? Or are we really looking for robo-taxis, autonomous mobility on demand services with or without safety drivers, delivering packages or moving people in a neighborhood or a city? A mobility ecosystem that provides seamless intermodal connectivity, moving people from home to the subway or steel-on-steel rail that is far more efficient. Or most importantly, as I would think of it, how do we begin to target a safety threshold that moves us towards the context of Vision Zero? Because living and moving safely is perhaps the ultimate target we should be looking to achieve. Now, obviously, there's different elements of the mobility ecosystem trying to pursue all of these components. These are big, complex problems in and of themselves. How do we begin to target where are we trying to achieve success so that we can find a successful end game in the quest for mobility? The hard part here is that we as drivers, humans in sitting behind the steering wheel, have a really difficult time understanding the human-machine characteristics of what our new role may be. As humans, we're really attuned to understanding, are we driving or are we riding? Am I responsible for the operation of this vehicle, or am I a passenger in the vehicle along for the ride? Now, as we automate more and we move forward in our pursuit of collaborative driving, we are going to need to define some middle points here where driving doesn't necessarily mean driving the traditional way. However, we need to educate the populace well beyond SAE 3016 to understand what an individual's role may be at any given point in time. And it very much is the human-machine interface that is critical to providing that context and understanding. And it is an understanding that we'll discuss in a moment here around data and why that understanding is difficult today and needs to be iterated forward over time if we are going to successfully deploy all the technologies we are working on. So how do we move people from understanding the foundations, from traditional driving to modern driving, and how riding may very well be different? So about 5 years ago, I led the development of the Advanced Vehicle Technologies Consortium to focus on collecting and analyzing data on how people are touching advanced driver assistance systems and other higher levels of automation in production systems in the field. So how do we get an understanding of system use, how drivers are adapting to use systems or not so that we can understand how they are behaving and begin to iterate designs of HMIs and the driver technology interaction dynamic that is happening on the roads forward faster. In essence, how do we get the industry to collaborate more strategically, learn from data, learn from each other so that we can engineer systems more effectively over time? The consortium is now supported by 4 OEMs, several suppliers, insurers, leading technology companies such as Google, and some of the key safety stakeholders throughout the world, including IHS, JD Powers, Consumer Reports, working together collaboratively to try to understand the complexities of system design development on our roads. So let's dive into a little of the data for a moment. Most importantly, and I'm going to switch over to the complexity of video today. Hopefully you can watch this clip. Comes across. Now, the largest supplier of production level automated driving systems is clearly Tesla at this point, with a number of traditional OEMs quickly moving behind. But is very much not the automation that Tesla is providing, and I'll play that clip again here. That's the issue. It's very much the interface to that automation. By any count, Autopilot is a sufficiently flawed automation system. It's not perfect. It cannot drive autonomously. It cannot handle the complex cut-in of a construction zone in this video. It's not expected to. But how do we ensure that the driver of that system understands that, is ready to take over, attentive to the situation around them, not fixated on doing things in the vehicle, to ensure that we are developing a mobility framework enhanced in safety? Unfortunately, the complex of designing appropriate technology and deployments in the car is incredibly complex. It's difficult to understand how people are going to use, not use, appropriately trust, and inappropriately trust technology on their own. It's no myth that with automation comes a responsibility for enhanced education. The aviation community has known that for decades. So when we look at other vehicles we're studying, Cadillac Super Cruise, for example, we see in this video clip right here a driver's first experience with Super Cruise, an automation technology that may very well be stronger than Autopilot from an automation perspective, but is far more advanced from an interface perspective. And again, I'll repeat that again. So Super Cruise, while many think of it as an automated driving system, is really a system designed around perhaps one of the strongest HMIs developed to date in the vehicle. Lead researcher on it, Chuck Green, works part-time with us now, retired from GM not so long ago. The behavioral adaptation system in Super Cruise is very unique. The system in particular is designed around an attention management strategy that is coupled with the automated driving system. So I think that is very important to understand. Literally building the automation, path planning control, to work coherently with the attention management system. So we begin to think about a transition pathway to appropriate use. How people move from level 0 manual control to level 1 ACC and over to Super Cruise level 2. We see that level 1 plays a very important role in how people learn about the technology, how they transition to the level 2 state, and how they transition back. And that interfaces in particular, if developed to support driver attention, motivate drivers, can be used cohesively to include them in that collaborative relationship and promote appropriate use of the technology. I'm not saying that any development today is perfect. I'm not saying that the second or third generation of Super Cruise that many are working on beyond GM and beyond GM won't be better than the first. I'm just saying that the unique characteristics of this system as it's designed are quite effective in promoting the appropriate use of the technology. So let's look at two specific components of this in video in particular. So let's call it, as it's designed, the blue state, or the manual override state. So in this case, when the driver here decides that they're going to change lanes, the automation is overridden and naturally re-engages to the green or happy state when it finds the new road piece. Again, that results in interface changes in the instrument cluster. That results in interface changes to a high amount light on top of the steering wheel, cohesively providing the driver a role in operating and motivating the automation. On the other hand, there is also states for emergent behaviors, such as the red state, asking drivers, using the mental model of red is bad, hey, it's time to take over. The automation is not supported in this operating context of a cut-in. Okay, red warnings go up, the alarms go off that I'm not playing here, driver needs to be attentive. What I'm not going to talk about cohesively today for time is the fact that there is an attention management system in here with driver monitoring and a management system encouraging the driver and mandating that they look at the road every 6 seconds, with the carrot being the automation use and the stick being, I'm going to take it away and lock you out if you don't pay attention. And it's that carrot and stick approach that we believe is very strong to motivating appropriate use of the technology. So I believe strongly that there are a number of other OEMs that have learned this, the fact that we need to motivate technology use and are moving there in the design characteristics. So one thing that we've also highlighted here in the context here of assisted cruise control is that when drivers are monitoring, there is a cost. And even level 1 ACC increases across 3 different vehicle characteristics here, Land Rover Evoque that we started some work with, Volvo's Pilot Assist, both the version A we'll call it and version B. ACC increases monitoring costs to the instrument cluster by over 50%. What's the state of the automation? I need to attend. Looking further, when Pilot Assist is engaged, increasing that automation monitoring cost over almost 200%. And 50% increase in glances to the interior of the vehicle. Not surprising. Version B is really the effective system, a topic for a later date. So the key here is that drivers have a role in successful automation. We've seen this before. It's not new. Automation-enabled systems such as electronic stability control and AEB are working to improve safety on our roads. They're not trying to exclude drivers from the decision process. They're alerting, engaging, and motivating them. Yes, automation is playing a safety role. Driver attention and perhaps the related situational awareness because of distraction in our lives may really be at a historic low. That means we are pre-attuned not to attend to the road when we are being supported by automation. Thus, increased automation needs to be coupled with increased mobility and safety. When we automate, we need to think about the driver's new role in collaboration, in monitoring, and being ready to take over, whether that is L2 or L3. To do this successfully, we are going to need new human-machine interfaces. I'm a strong proponent of monitoring, managing, and motivating drivers. And from some of our early work done for Ford in the 2005 to 2009 range, we began to outline some of those contexts. The driver is an integrated role. The aviation industry discovered this among pilots in the early 80s. Replacing pilots was not the answer. Augmenting the automation in cockpits with pilot skill is where we have gotten to in aviation safety today. So can the driver maintain sustained attention when they're making a decision at any point, whether I should monitor a machine or should I drive? The answer is very much no. We can't do that. And that is one of the reasons that when we look at the deployment of Tesla's autopilot, drivers are struggling so much. The key here is two-way collaboration, bringing driver monitoring and management into the equation so the system is monitoring and managing the driver and understanding where the driver is attending, and the vehicle automation knows what the state of the driver is and where they need to be supported. It's mutual support. And that support can lead to a more comfortable, more trusting, and more successful relationship with the driver fulfilling their role and the automation supporting them to make driving more comfortable and convenient. A topic we can talk extensively on at a later time when time allows. So the real key here is a deeper understanding of attention management. Really trying to manage driver workload at any given point in time on the traditional Yurtse's dots time curve, alerting them when they're inattentive and fatigued, and ensuring to calm them when they're actively distracted or overloaded. Perhaps we really have been looking at the entire distraction problem all wrong. We need to look at it holistically across the system as an attention problem. What we classically thought about as distracted driving, picking up your cell phone and driving, is really filling the attentional void of driving being too boring. We can help drivers fill that role strategically in a more safety-conscious way. In essence, looking at the driver problem as an attention management problem as opposed to a driver distraction problem or a driver monitoring problem. How do we help the driver at any given point in time make better decisions? Looking at the road when they need to, and getting some of what they want done while they're driving, threaded in between. Some work that we pursued as part of the AHEAD Consortium over the last 7 or 8 years really looks at this in the context of an attentional buffer, encouraging drivers to look up frequently enough to acquire the situational understanding needed to make downstream decisions. Some of the work here is really pointed to when you look at the relationship of time looking away from the road with time looking at the road, you can begin to see divergences in attention that are predictive of crashes in ways that the industry has not seen before. The foundational model can be used to design interfaces much more coherently than global standards do today. In essence, following the context of interruptibility and encouraging drivers to look at the road long enough to acquire the information needed to make downstream decisions. We often look up for a brief second, say the environment hasn't changed, and look back down too quickly, failing to see changing threats in the world around us. So when we look forward, advances in HMI will be critical to supporting both drivers and, over time, riders. As we automate more, information needs will increase. Drivers need to know where the system's working and why. They need to be educated to build trust over time. Trust erodes quickly. We need to build it and encourage it. We need to build new infotainment displays, new visual displays. The picture on the right, drawn from Veoneer's Learning Intelligent Vehicle that has been demonstrated at CES the last few years. Mode awareness, mode confusion being things that we can use visual information to help support. We need to look at more effective multimodal interfaces. Haptics are incredibly important. Visual indicators high on the dashboard. Auditory cues only when needed. Innovate forward in the context of driver state management, helping drivers make better decisions. I'd also add that we need to innovate on the EHMI, the external side, to communicate expectations to potentially salient situations. Advertisement space will become critical. So it's really the integration of communication, infotainment, and safety systems through synergistic HMIs that is critical to the automated, electrified, and connected mobility system that we are all changing. It's all about how you connect it to us, the user. So in closing here, While the future may be autonomous, and unfortunately the full context of autonomous mobility could be the best part of a century away, the next few decades will be one of collaboration. Significant changes to how we live and move will take decades to unfold. We will see higher levels of automated vehicles emerging, whether that's delivering groceries, picking up passengers, and the improved business case of how to make money here will evolve. The key may be managing consumer expectations through this process. Right now, drivers are looking for a riding experience. You're not going to find that in the neighborhood anytime too soon. Ensuring that when they go to the dealer to buy their next car, their expectations are grounded. Because the industry needs to continue to excite and delight customers. Well-conceived policy or industry collaboration is needed to ensure appropriate standardization across platforms. I'm not sure we know what to standardize now, but we do know how to build guardrails to keep this industry moving safely and securely forward through the automated development processes. Connecting the human to this is critical, and human-centered engineering through the design, development, and deployment of these systems is critical. It's all about trust. We need to build a trusted, safe mobility system. We can't walk out of roads, much like the global pandemic that's around us, worried about what's going to happen. Safety and security needs to be key. So I believe strongly that collaborative driving deployments can become, at least for the foreseeable future into the next several decades, a savior to the automotive industry. There's no mystery that robotaxis will be driving around a century from now. But let's look at collaborative systems. Much like Super Cruise is illustrating we can do GM's context, but many others are following to how we motivate drivers from the traditional context of holding the wheel to the new world forward of collaboration. And I think it's important, as highlighted in the Forbes piece that I just posted back in January, that we need to take initiative, Tesla leading the way, to better monitor and manage driver behavior, and calling for the industry to work together to develop deployment standards there. And with that, I will close and look forward to the question session later on.
So thank you very much, Brian. So it was, I think, very interesting. And we see that there will be more and more collaboration between the vehicle and the occupants. We also saw that we need more multimodal interfaces between the occupant and the vehicle. And of course, trust is a very important topic that we need to get in the end. So now let me introduce Omar Ben Abdelaziz. So he's a racing engineer within FORCIA, so he's currently managing innovations related to user experience within the FORCIA Cockpit of the Future team, and he's confronted to sensing technologies and all kinds of technologies to achieve closed-loop functions. So, Omar, the floor is yours.
Thank you, Christophe. Thank you, Brian, for this interesting presentation. So thank you for all of you for your participant. So today I will try to speak about the technology and the approach we use to decide on the technology, the approach to use to decide on technology to use to monitor what's happening inside the cockpit. So this is why, and being part of Cockpit of the Future, I would like to share with you these two approaches. We have a blue approach and a red approach, as you can see on this slide. The blue one is a customer, it's a user-centric approach where we start from the pain point, the need, where we start from identifying the need of the user. We try to think about the experience we should offer to the user, and then we link it to a product, and then we think about the technology. This is the approach we are using at Cockpit of the Future today, and this is how we are working within the team. And we have another approach, which is the red one, where we start from the technology, we build a product, and when within this product, we build an experience and we push it to the user. At FISITA, we call it the techno-push approach. So both of them are, let's say, interesting as approaches, but the blue one is making more and more sense, especially for the cockpit of the future, to tackle all the pain points of the user. Now, if I move to the next slide, I will speak a bit about the HMI time. It's the subject of today's conference. The HMI is one of the experiences we would like to ensure and to guarantee inside the cockpit of the future. And to do that and to keep the user experience, we are working on 5 trends here, and we try to respect those trends to keep the HMI as lean as possible inside this cockpit. So here we have 5 trends. The first one is the optimal first-time user experience. When we first start using HMI, we would like that the HMI should be as intuitive as possible. We also have another trend, we call it interaction with living creature. This is linked to multimodality, linked to personalized experience. We gave here the example of Nomi from NEO, which is a very good example of such interaction. We also speak about seamless interface, where the interface and the connectivity should be as seamless as possible. We think about also an HMI which is adaptive and smart enough to appear and disappear depending the context and depending the situation. And the last we have trend, we have ageless HMI, where we have some golden rules which we would like to keep and to use in the car of the future, within the cockpit of the future. So this is one example of experience, but at Cockpit of the Future, we are considering several experiences. On top of the HMI, we can think about all those experiences and the difficulty to monitor what's happening inside the cockpit, and to be able to detect this situation and to be able to offer the service at the right time and to the right occupant. So this is why this experiences will bring us to speak about sensor technology and the way how we should monitor the cabin and the occupant to be able to keep the user experience at the same level that we have in mind when we designed the product. So if we look to this approach, which is a top-down approach where we start from the UX need, the UX concern, we have here several concerns linked to wellness, health, safety, and HMI. Each of them has some attribute to measure, or will lead us to measure attribute on the occupant body, on the cabin, or attribute from context. Those attributes will be measured with technology, and this is helping us to decide on the technology which sensor we should use to measure the attribute and to reach the UX. So it's a top-down approach which help the automotive industry, or it's helping us to offer a system capable to tackle the needs and to pain points of a specific occupant. Now, and as we can see, the question here is one sensor with one technology is capable to detect a situation as the one I presented just before, situation for a comfort situation or a safety situation, or a very complex one with different occupant, where each of the occupant has a specific experience. So this is why here we speak about data fusion and closed loop monitoring concept. This is a concept where we will try to make use of all the data source we have inside the cockpit, fuse them, and offer the right services afterwards. So let's have a look and let's see how this system works. So we start from the use case. The use case, as I said, could be a simple use case, like detection of an occupant on the seat, and then maybe one sensor will be enough. But when we speak about stress detection, when we speak about the mood detection, when we speak about the drowsiness detection, one sensor will not be enough. and multiple data source will be mandatory to monitor what's happening inside the cabin. So this is why we have here a bench of available sensor inside the cockpit of the future, which will feed us with a lot of data. So the first sensor I put here is an anterior radar. This anterior radar is a millimeter wave radar with a multiple input, multiple output antenna. We speak here about different frequency range, like 60 gigahertz, 79 gigahertz. There's other ranges also, like 24 gigahertz and 120. We have also some technology like beamforming to deal with the radar waves. We have also camera sensors. I would say the camera is maybe the most important sensor for the in-cabin monitoring system. We have different technology of cameras. We have near-infrared camera. Here I mentioned the wavelength of 945 millimeter nanometer sensor. We have also thermal camera, which is capable to measure the temperature of the human body, especially the temperature of the face, and decide on their comfort level or on their stress level and things like that. We have also NER RGB camera. This NER RGB is it's a hot topic now because there's a lot of requests today asking for such kind of sensor, because we are trying to enlarge the scope of a single camera to do NER capability camera with a full color camera to make, for example, selfies or to make a conf call use cases. We also have some 3D camera, like a time of flight camera, structured light camera, or a stereo camera. We speak about also a stereo camera, which is not mentioned here. We have the seat sensors. The seat is a very important product to monitor what's happening and to assess the situation, because the occupant will be always sitting on a seat. It will even remain in the future. We will have always this remaining contact between the body and the seat. And there we speak about some sensor technology like piezo sensors, capacitive and resistive sensors. We have also biometric sensors where PPG is used to measure the light reflection of the skin and to decide on the heart rate, the breath rate, and the oximetry. We also have some air quality sensors and context and smartphone and wearable sensors. All those sensors data are sent later on to a data fusion engine where we fuse all this data to decide on the situation. When we decide on the situation, then we have a dynamic rule engine, which is able to select the right action depending on the situation and then send it to our smart actuator. We will not stop there, because our system will be capable to loop and send again to monitor what's happening and what is the effect of the action on the occupant. And we will still looping until the solving of the situation and until enhancement of that situation. So this is the slides I had for you today. This is the presentation I prepared for you. Hopefully it was clear. Don't hesitate to put your questions, and we will try to answer them and during the Q&A session.
Thank you, Omar. So we wanted to put some, of course, technologies in the presentation. So we can see that there are plenty of technologies and functions which are emerging today and which are not stabilized, especially the robustness of the technology versus the cost, because within the automotive industry we need low cost. But of course there will be some convergence within the next 5 years. At least we hope so. So now we have to we go to Philipp Kemmler Erdmannsdorfer, so who is working within NIO. So he's a senior manager communications and public affairs at NIO. in Germany. As a company spokesman, is responsible for all internal and external corporate communications for Europe, as well as for maintaining political relations. So he's going to show us how NEO has already developed innovative HMI solutions to improve user experience and safety, and what will come in the future. So we thought that it would be very interesting to have NEO with a new OEM, so with no past, I would say. So they are very free to invent whatever new function, whatever new environment within the automotive industry and within the car. So I leave the floor to Philippe.
Merci mille fois, Christophe, and a warm hello from Munich. It's great to participate here, even though I always wanted to give a presentation the same lineup with the MIT, so that's pretty cool. I'm filling in today for Kaveh, our UI UX director, who is unfortunately not able to join us today. So I'm sorry for me not probably being a bit less technical as he would have been. But I'm a social scientist, so please excuse me for that. Nonetheless, I try to give a little overview of what we are doing at NEO, how we would like to proceed in terms of HMI, proceed in terms of digitization, in terms of creating a new environment within the automobile industry. So a few words on NEO for those who haven't learned about us yet. So NEO is a new generation car company. It is founded in 2014, so it's pretty young still, and is born in the mobile internet area. So for us, digital features and digitization is a determination in the future of the car. And that's why we try being as much digital as possible from the beginning to satisfy the demands of user and potential future customers. So it's our strong belief that digitality will redefine the user experience in the whole industry, and therefore most likely the whole business model around the automotive industry and within the automotive industry. I think because of this, we're gonna see a lot more of human-machine interaction within technology, and whose ability will also become far more important than it is now. So we do see a lot more of research, not only from computer scientists or engineers, but also from psychologists. For example, how humans are interacting with the machines. So our competitor around the corner, Audi, for example, has his first HMI test units where psychologists are testing how humans are interacting with the machines. So this is where we currently are at NEO. We came from the performance side, as you can see. This is our Formula E race car where we started off engineering. Meanwhile, we are selling 2 mass production vehicles in the Chinese markets, our performance SUVs, the ES6 and the ES8. And like our competitors, we consider autonomous and connected driving as one of the key features for future cars. And so our San Jose team in California is researching and developing together with the colleagues from Intel Mobile's these technologies. And as Brian already said, there is still way to go, but I show you a little video where we are right now with our development.
At NEO, our focus is on people and enabling a joyful lifestyle with mobility solutions. The big benefit with autonomy is a reduction in accidents. 95% of those are human error.
And a big part of that is due to driver distraction and fatigue. Autonomy really takes all of that away.
The entire ES8 vehicle is built to be China NCAP 5-star rated. The ADAS system plays a major role in that. It's going to have automatic emergency braking for vehicles, lane departure warning. The entire system is really designed to make you a better, safer driver. NeoPilot includes traffic jam assist. If you're stuck in traffic, you're not having to modulate your brakes and your accelerator. The system's doing that.
When it comes to extremely difficult parking, like in China, we have the most advanced ultrasound system in the market, and that allows you to start tracking an object all the way down to near zero. In addition to the ultrasound, you have 5 radars, 1 long-range radar and 4 corner radars. From there, we have a more advanced trifocal camera system in the front, as well as an interior cockpit camera.
Hardware and software are the pillars of autonomous driving. We are able to process the information that is coming through sensors and feed that into our algorithms, which are responsible for decision-making, path planning, and control system design, while hardware can send the messages to other components in the car.
With the connectivity that we have in these vehicles, if we want to implement a new feature, we can deploy it into customer vehicles and analyze its performance before it's actually activated in a customer vehicle.
When we are developing a new functionality, we can replace real miles with virtual miles. In an hour worth of simulation, you can probably run 60,000 miles. So running several million miles per day is not difficult at all. Every kind of situation that is not safe on the road can be done in simulation.
So, yes, this is where we are right now with the development. I hope this is now going back to the slides. Yes. But where is this development going? So in 2018, we presented at South by Southwest, where we see this future headed for. Neo Eve is our vision car, and this is the vision of the already fully autonomous vehicle. So in this vehicle, of course, the interior will become way more important. Especially in that case, the human-machine interaction becomes very crucial because you have to interact with the machine you are riding in while also feeling safe and using other features around that. So features like smart glass and other intelligent steering options will implement new ways of interaction with the machine and the car and your environment, and of course artificial intelligence devices. We also were having an interesting use case for new materials put into the future-oriented car. So I show you another little video what this will look like.
In the future, my car is going to be like a spaceship with wheels. It'll have special powers. If I called, it would come and get me. With just a wave of my hand, the door will open, just like magic. It'll recognize me. It knows how I feel, what I'm thinking. And it will drive all by itself. It's just like home. It's just like my living room. I can feel safe and cozy. My mommy and daddy can sit together, talk to their friends 1,000 miles away, while I can sit in the front, all by myself. I can discover the whole world. Go on adventures. When I get tired, there will be a seat so comfy it feels like a cloud. Stars. I can see all the stars. There's the lion. while I'm asleep, my car would watch out for people in the street. It'll speak to other cars in a secret language. And it's going to look so cool. Like it's from the future. One day, it will be real. And I'll call it Eve.
So that was a glimpse into the future, but back to reality. So, as I mentioned AI devices before, we have created Nomi. As already Omar said before, this is probably the most advanced HMI system in our car at the moment. And Nomi is a deep learning AI machine, an artificial digital companion in the car. It's probably a bit comparable to Alexa. It's more like an assistant, but you can use all the features which are implemented in the digital feature system of the car. And it was the decision that as long as you are driving yourself, a voice control assistant will create less distraction from the street and makes you more safe in your driving. But it was clear from the beginning that it also should be having more features, and therefore it was a deep learning algorithm implemented. And a nice, for some Europeans, probably a bit odd example is a story happened in China. So there was an elder customer couple having a sick cat, and this poor sick cat was needed to be taken to the vet in regular amount of times. So they were driving with this cat to the vet, and after a while the cat died. So the AI system in the car realized that the couple wasn't driving to the veterinary clinic anymore. So it was asking if somebody has happened. And then the couple explained that the cat has died. So the AI was informing the customer care service, and they sent the couple a morning gift. So as I said, it might be a bit odd for some taste, but in China it was working perfectly. And that's also a nice example how in different areas of the world those digital features in the interaction with humans can differ. But I also have a little video on the functions of Nomi as well for you. Might be a bit for Chinese taste as the cat story, but nonetheless it shows the functions quite nicely.
早上好。
早 ，Nomi。
我们出发吧。
嗨，Nomi。播放上一首歌。
没问题。
声音大一些。
Nomi， 我们来张合影吧。
好的，准备好了吗？3、2、1 ，Nomi。
你看脸了。
Nomi，我们回家吧。
So as you can see, Nomi can read the barcode of a delivery and open the trunk for in-car delivery. Another example for digital features is cloud-based services, which are also very important in the customer experience and the customer journey. But even more important are the power services provided by that. We have different possibilities to charge the car, and to ease up this process, since range anxiety is still the biggest hurdle in buying an electric car. So to ease up these processes, cloud-based solutions are enabling the best possible charging solution for the customer where he is located right now. Whether it's our Power Mobile, which is kind of like a power bank on wheels, a DC charging possibility where you can just DC charge the car, or a fully automated power swap station where you can just swap the battery. Which is also a nice feature because it also enables the user and customer a very easy way to gain full reach of the car again without spending more time as you would spend on the pump. So a swap process at the moment is around 5 minutes. This is summoning up all in the NIO app. This is the core piece at the moment of our digital features. So as you are used in China, it's kind of a super app. And it's kind also of the NIO microcosm on a digital feature side. So besides the car functions, you can, of course, as we know from Tesla, you can also steer all your car function with the app. You can also use different other solutions for the car. So you also have a community tool in there. You can also participate in different activities featured by the company and giving you a more human touch with all these more cold technical features. But it's also, and that's, I think, a very important thing, it's also already used to the customers and to the users because they are used to their mobile phones and they are used to online applications. So enabling a digital lifestyle is also enabling, or we try to enable with that, a joyful lifestyle for our users, and also implement with digital solutions for future products that this is very easily being implemented in the car, and via over-the-air updates are going to be featured for your product, so that new functions, for example, when it comes to the development of autonomous driving, at the moment we are at autonomous level 2.5, but if there are new features being developed by our teams, they are going to be sent over the air to the car because the technology hardware side is already implemented in the car and can be updated for the customer without having any pain points or needed to go to the garage or workshop. So I'm also looking very much forward to your questions and hope you kind of enjoyed my not that much technical presentation. Thank you very much.
Thank you very much, Philippe. So we can see that NIO has a global vision of the human-machine interaction, and you have already implemented some of them when we see Nomi, for example. So now I think we have some minutes to go to the question and answer. So we can take 5 to 10 minutes. So maybe if we start maybe with Philippe, maybe. From your point of view, Philippe, when will NIO be put into the market?
I hope as soon as possible. At the moment, we are exploring, of course, different market opportunities, and we are working on the implementation for the European market, but it's not that easy. We do have, and this is at the moment the biggest problem, different charging standards. In China, we have a standard called so in China we do have a different standard than CCS in Europe, and it's quite difficult. And this is again machine-to-machine interaction, because the car has to interact with the charging column, for example, to provide the most best charging opportunities for the battery and for the car itself. So we're working on it. We're looking into a period from 1 to 2 years right now.
Okay, thank you. So we have some questions to Omar. So maybe I'm going to ask one, and then I will go to Brian. So radar or LiDAR, which one is preferable? Is the use of millimeter wave radar allowed in all countries for ADAS or autonomous car? Of course, we have more spoken about interior of the car,
Yes,
but
yes.
maybe Omar, you can answer.
Yes, it's the presentation I made is for the interior of the car. So we are speaking about the millimeter wave radar. Now there is some also investigation of using LiDAR inside the car, but we don't think that we will need such expensive sensor inside the car, and the radar will be more than enough to cover the use cases we have in mind. Now, the second part of the question was about the usability of the radar inside the car, and is it allowed or not, depending the country. This is a very good question, because today there is a very big discussion about what is the frequency range we should think and we should use for the interior radar. There is a discussion about 79 gigahertz and 60 gigahertz. So discussion is always ongoing. There is no decision yet, but we see that in US, for example, 60 is it's close to be selected as the main frequency range for this interior radar technology. And just one main use case for this radar will be to detect the child left detection inside the car. So it's the main application for this interior radar sensor.
Okay, thank you, Omar. We go to Brian now. So your presentation, Brian, highlighted the need to monitor the driver's attention, even for L2, level 2 cars that are being sold legally. Do you think that such cars without driving monitoring should be forbidden, taking into consideration proven cases of sleeping drivers?
That's a very good question. And I think that in the context of what we have done in the past, one has to really focus forward. I do believe the industry should collaborate together to set a deadline, call it, 2022, 23, 24, 25 model year, where no L2 vehicles are sold without driver management. I don't find it really ethical for manufacturers to be selling vehicles where drivers can fall asleep behind the wheel of a car. The technology exists to prevent that at this point. I think there are a whole lot of technical questions around the specifications of deployment, but this is one reason that I called in my January Forbes post for the industry to work together in the US, much like the joint collaboration between IHS and NHTSA to form an industry collaborative agreement around AEB to do the same for driver monitoring and management in the car. And I am fully supportive of the Euro NCAP's efforts in the EU to do the same. I think we need to take a responsibility with the deployment of automation that remembers with the loss of control comes a loss of responsibility, or a change in responsibility. And from the design side, we need to embrace that, much like the aviation industry has over the last few decades.
Okay, thank you. Another question for you, Brian. Humans will not be aware of the level of the car autonomy when they sit in the car. They might have different mental models on the provided level of automation. Is there a sequential development for L0, level 0, level 1, level 2, 3, 4 meaningful?
I think that's also a very good question. I think the development of the levels is applying what the Society for Automotive Engineers meant to be guidance for engineers developing systems. That may make sense from the engineering side. From the consumer side, it makes no sense. it's not sequential. We need to develop the mental model of the use case, which means that education is imperative. There is no mystery. With increased automation of all levels, we are going to need to develop the education pipeline that goes with that. That means a future vehicle at the L2 or L4 level will need to develop onboard and perhaps off-board education approaches to support that development of an appropriate mental model. I, for one, don't believe that level 3 systems, as they are being construed today, really do make sense in this pipeline from the consumer perspective, but very well they need to be there from the testing and engineering perspective to develop meaningful level 4 systems of future.
Okay, thank you, Brian. Question to Omar. Are you integrating augmented reality with HMI, or do you plan to use it?
Today we don't have it, but we plan to use it. We have a project to develop this kind of HMI inside the car. It's not only for outside of the car, but we are trying to use this augmented reality inside of the car to enhance the user experience and to well communicate and well interface with our occupants. Then the answer is yes. It's something we are focusing on.
Okay, we come back to Brian. The following question: how to optimize the driver assistance and warning system to avoid unnecessary false warnings?
Yeah, that's a good question. I think unnecessary false warnings are a big problem with active safety development today. And part of that is often the deployment of systems that are really in need of broader testing and operational characteristics outside of their design domains. But some of the false alarms are really a failure of expectations and understanding when and where a system should alert based upon how it's built. So while we may have a hard time suppressing all of what a user may believe is false alarms, understanding the context of use is probably the key there. And advancing sensor design and development further and faster before we bring systems and deploy systems in front of the user. So if we look at early stage forward collision alert systems as a great example, the early systems had very high false alert rates. Systems being developed today are much more manageable. And again, it is deploying things too early that may erode the trust in future systems. It's very much a balancing point.
Okay, maybe 2 additional questions because the time is running and we are already out of the time we wanted to spend. But one additional question to you, Brian. How do we overcome the challenge when the machine thinks the human is in control and the human thinks the machine is in control? What awareness model can help in design?
Yeah, that's also a good question. And that's why if you look at one figure I put up, it's very much about the machine having a conceptual strong understanding of the human and the human having an understanding of the machine and working with the driver management system to fill that intermediary gap. I don't think we exist today with the technology to do a robust enough monitoring and management job in the car and deployment systems to do that. But as your future cab context illustrates, the sensing technology to have replicable and overlapping sensing characteristics fused together in a model to really do that is on the horizon. So it is very much of using multimodal and central information from the human to feed into the automation system and from the automation system to feed back to the human. If there is not a trust between those two systems, it's an illustration of a case of where traditional driving may be the fallback mechanism we need to move to.
Okay, maybe a last question to Philip, and he will tell us if he's able to answer or not. Could the AI, like Nomi, actually teach the driver to pay attention to the road, help him or her to develop good habits, and based on the result, enable or disable driving assistance?
Well, that's a really good question, and I really like it. I guess it's a very philosophical question, isn't it? Is it the machine to teach us something. So probably yes. Probably in the context of safe driving and committing something, but in terms of self-fulfillment and fulfilled being and human beings, I don't know if I want to be taught and educated by a machine. So I probably leave that questions to the philosophical department. But it's very interesting to think about that and to discuss this.
Okay, so I think we are at the end of this session, this interesting online conference on HMI. So I would like to thank all the panelists and also all the attendees, and we hope that it has been valuable for you. We are considering to do another online conference. It will be on June 24th, and it will be dedicated to intelligent vehicle dynamics and control. So if you are available and interesting, you can, of course, connect and register online on the FISITA. So thank you to all of you, and I would say take care. Thank you very much.